So what is a derivative? We're going to cover this later on, obviously, throughout the presentation, but the basic idea is that a derivative will give you the slope at any point in a function. We're going to explain this more in depth, obviously, as we go on. So first let's cover what slope is. Now this is obviously a really easy concept. You probably all already know this, but let's say that you have 2 points, x2 and y2 and x1 and y1. You want to find the slope from here to here. You take the y values and you subtract them over the x values. In other words, you take the rise over the run. The rise over the run, right? So that's what slope is. Now, if you want to find the slope of a curve, it's a bit harder. You can't just use that formula since a curve is not a straight line. You can, however, find the approximate slope using the slope formula. And the way to do that is using a secant line. And a secant line is just a line that hits 2 points on the function. That's all a secant line is. A secant line hits 2 points and only 2 points. And obviously you can find the slope of a secant line. So the closer the points are, the more accurate our approximation is actually. So let's take these 2 points, x and y, and x plus h and y plus h. The slope for that secant line in this example right here is the y coordinates, which is f of x plus h minus f of x all over h. Now this is actually pretty important. You should really memorize this because it's going to come in later. Now let's go over what a tangent line is. A tangent line is a line that hits the curve at only 1 point. A secant line hits it at 2 points. A tangent line hits it at only 1 point. Now we can move the 2 points in a secant line infinitely close to each other to actually create a tangent line. So we can find the slope of a secant line. We can actually also do it for a tangent line. So now we're going to cover what a derivative is mathematically. So this is our formula for the slope of a secant line. It's just rise over run, right? And h represents the distance between the points. Now a tangent line is basically just a secant line where the points are infinitely close. So h is actually approaching 0, right? So the equation of the slope of a tangent line is basically the same as a secant line as h approaches 0 because the points are infinitely close, right? So using this equation, you can actually determine the slope at any point on the curve. And that's actually what the definition of a derivative is, as I said in the beginning. It's the rate of change at a specific point. It's the slope at a specific point. And I basically just said what it is in layman terms. It's the slope of a curve at a specific point. So for those who don't fully understand the f of x plus h part in the limit definition of a derivative, specifically this part, you don't know how to use it when it comes to math. Like, you don't know how to plug that in and use it mathematically. Let's just cover a few examples of what how we can actually use a function, just to clarify your understanding of it. So let's just say that we have a function f of x equals x squared. Now if I told you that you wanted to plug in 3, all you do is replace everywhere where you've seen x with a 3. If I told you to plug in 8, you just replace everywhere you see an x with 8. Now we see an x in this location right here, so we're just going to replace it with 8. If I told you to replace it with apple, you just take the apple and then you wrap it in parentheses because that's what the x is. You're literally replacing everywhere where there's an x with apple. So let's look at f of x plus h. So let's actually just cover it in an example, just to clarify, because it's pretty tough to understand. So find the slope of a curve, f of x equals x squared, when x equals 3. So plug x equals 3 into that formula, the definition of derivative. You need to memorize this, by the way. So we're going to plug in 3 into the this formula right here, and we're left with 3 plus h squared minus 9 all over h. And then what we're going to do is FOIL, right? So we're just going to do some math, some basic math, and then we're going to factor out h. The 9's cancel out, obviously, and then we're going to factor out h, right? And then the h's cancel out, and then you're left with the limit as h approaches 0, and you're left with 6 plus h. So your final answer is just going to be 6. So the slope of the curve x squared when x equals 3 is 6. We're actually going to cover a super easy way to actually just do this without having to use this formula right here, and it's called the power rule. We're going to cover it eventually. Now it's important to note that a function must be continuous at a specific point for it to be differentiable at said point. So if a function is not continuous at a certain point, you can't take the derivative at that point. So that's it for this presentation, but we're going to cover the power rule in the upcoming lessons.